Good morning, everyone. Welcome to webinar 3 of this Lynx webinar series. Today we have a technical webinar. So for those interested in the technologies behind our Lynx Services Platform, what we call LySP. So our aim today is to give you an overview of LySP, architecture and basic services. And next Thursday at 10:30, we will show you in more detail the rest of services, annotation services, search and information retrieval services, machine translation, etc. So please don't miss the next webinar either. Okay, so this is, our agenda for today. As you can see, architecture and basic services, I'll be accompanied by my colleague, Filippo Maganza, software developer at Alpenite, and Sotiris Karampatakis and Victor Mireles Chavez, both senior researchers at Semantic Web Company. Okay, so for those who join us for the very first time, I will give some basic info on the Lynx project. Yeah? Lynx is an innovation action funded by the European Union under the Horizon 2020 Framework Program. And the topic, as you can see on the slide, Big Data PPP, Public-Private Partnership, cross-sectorial and cross-lingual data integration and experimentation, which means that Lynx is also part of the projects under the umbrella of the Big Data Value Association, BDVA. The initial duration of the project were 36 months, now extended to 40 months due to the pandemic. But we're coming to an end. The end of the project will be the 31st of March. There you can also see the estimated project cost, the contribution by the EU, and the name of the project officers in charge of this project. Okay, who are we? So as you can see on this map, most of the partners are located in Europe, and one partner is an Israeli company, K Dictionaries, a dictionary data provider. Then we have 3 universities in the consortium, UPM, Universidad Politécnica de Madrid, coordinators of the project, University of Zaragoza, and Autonomous University of Barcelona. We also count on the research center, DFKI, the German Research Center on Artificial Intelligence, a language technology company, Tilde, from Latvia, Semantic Web Company, a provider of semantic technologies, Alpenite, an Italian system integrator company, and then representing the 3 business cases in the Lynx project, we have Saibli, an Austrian legal tech company, the international law firm Quattro Casas, and the MVGL, a Dutch-Norwegian industrial certification company. So these are the 3 business the companies representing the 3 business cases. In webinar 2, we already presented and demoed the solutions created for these business cases. So if you missed that webinar, there is also a link to the recording in this slide deck that we will provide to you in about a week. Yes, together with also with the recording of this webinar. Okay. What have we tried to achieve in the Lynx project? So broadly speaking, the main objective was to overcome the difficulties that companies in Europe face, yes, due to the fact that legislation and regulations are published in different formats and according to different criteria, and especially in different natural languages. Yeah. So our efforts have been devoted to create an ecosystem of smart cloud services to better manage compliance, and this is LySP. This is what we will show you today. This ecosystem of services is based on a knowledge graph that integrates and links heterogeneous compliance data sources, including legislation, case law, standards, and other private documents, right? And all of these across languages and jurisdictions. Okay, here we have the 3 pilots, the 3 business cases that I just mentioned, one on contract analysis, labor law, and geothermal energy compliance. Yeah, so this was a brief introduction to the project objectives and results. And now I will hand over to Filippo Maganza, who will explain the link architecture. But before I give the floor to Filippo, I would like to thank the speakers joining me today. I would like to thank the audience again. Yes, let me remind you that this webinar is being recorded, that you can put your questions into the chat. Yes, that we will have some time for questions at the end of the webinar. And yes, that I hope you really enjoy the webinar. Okay, so now, Filippo, the floor is yours.
Thank you, Elena. I turn on my webcam. Okay, you should see me now. Good morning, everyone. My name is Filippo Maganza, and I'm a software developer from Alpenite, an Italian software integrator company. In this section, I will present the basic principles of the Lynx architecture, describing for each of them why they are used and their main idea. The aim is then to provide a list of reusable architectural models and design patterns addressing specific requirements or scenarios. We start with a very general scenario, which is the development of a large software project with complex requirements. The microservice architectural pattern addresses these scenarios by breaking software into smaller and loosely coupled parts, each of which can be developed and managed by small dedicated teams. The question is then how we can divide the application into microservices. This problem is often not straightforward to solve, since there could be many possible organizations. However, there are two rules that helps us deciding which organization to prefer. Let's zoom in a bit on these rules. Let's start with the bounded context. Can you go next slide, please? The bounded context rule refers to the coupling of service components and their data as single units with minimal dependencies. In the bottom, you can find an example which goes against this rule. As you can see, there are 4 microservices named A, B, C, and D, and many dependencies among them, represented with the arrows. The question we should ask ourselves to understand why this configuration is bad is, what if B changes? The typical answer is that we need to check whether C and D have been affected in a negative way by the changes of B. And this is usually a very time-consuming task, especially for a team which should not have much knowledge regarding C or D. Next slide, please. Next, we have the single responsibility principle, which states that each microservice should have only one reason to change. That is a single tightly coupled group of people representing a single narrowly defined business from which changes can originate from. As before, in the bottom, you have there is an example which violates this principle. In this case, there is a single microservice responsible for both search and the name identity recognition. And as you can see, there are 2 tightly coupled group of people from which changes can originate from. This time, the question we should ask ourselves to understand why this organization is bad is, what if people from information retrieval and natural language processing request changes simultaneously? Well, the probable answer is that developers should synchronize their work to some extent, implying a loss of time. Also, another problem is that by breaking this principle, we decrease the fault tolerance of the system. So we should avoid this situation. Next slide, please. Okay, this diagram shows how we organize the Lynx application into microservices and how these microservices interact with each other and with the external services. As you may notice, most of the dependencies involve the workflow manager component, which acts as an orchestrator of services, both internal and external, in order to achieve coarse-grained functionalities. This component, this kind of coarse-grained functionalities will be addressed in a next section of the presentation. Next slide, please. The requirement we now discussed is designing an interoperable web API. Interoperability here means that the API should easily integrate with different types of clients. With respect to this requirement, the REST architectural style defines a set of useful principles. These principles revolve around the notion of resource, which can be thought simply as a piece of information which is possibly subject to change. Then the basic principles that REST provides are resources must be uniquely identifiable through URLs. Clients can manipulate resources through their representations using the set of semantics specified by the HTTP protocol, get, post, put, delete, and so on. Then each HTTP request must contain all the information necessary for the server to understand the request. This implies that server sessions are not permitted. Okay, next slide, please. A good documentation has often fundamental importance for our REST API. The OpenAPI is a description format for REST APIs, which is useful for different reasons. It helps structuring and analyzing the documentation. It can be easily interpreted by both human and computers. And last but not least, any document compliant with the document can be visualized and tested using Swagger UI. Hence, a web user interface for the REST API is provided out of the box together with the documentation. Next slide, please. This is a screenshot of the document, of the OpenAPI documentation of the document API of Lynx, visualized using Swagger UI. I forgot to mention that Swagger UI is a web application developed by the same company who developed also the standard, the OpenAPI standard. In the bottom of the screen, you can find both a link to the Lynx API portfolio and to the Swagger UI webpage, where you can, of course, download the code and test it by yourself. Next slide, please. In order to create a web API using a microservice architecture, it is often useful to decouple the exposed web interface from the underlying microservices. The API gateway pattern can be used to address this problem. The main idea is having a single component which acts as entry point of the system and routes requests to microservices accordingly to some logic. In the right, you can find an example which shows how we used this pattern in the Lynx project. You can see that the collection resource has many sub-resources, documents, top K, documents, question answering. Each of these sub-resources is provided by a different microservice. And without this pattern, with this API gateway pattern, it wouldn't be possible to have such an organization. Next slide, please. Using a microservice architecture, we often have to deal with the problem of managing business processes that stretch across the boundary of individual microservices. To address this problem, Lynx uses the service orchestration technique, which consists of a central brain that drives the business processes, much like the conductor in an orchestra. The Lynx component responsible of service orchestration is the workflow manager. And the fundamental business process it orchestrates is the population workflows. As I said before, this component and this model will be explained in detail in one of the next section of the presentation. Okay, please, next slide. Sorry. To simplify integration of services into business processes and with the external world, we designed a model for the REST API of enrichment services, which are those services responsible of adding knowledge to documents, to existing documents. To this end, the enrichment interface consists of two contracts. The analysis API, which uses a post method, takes as input a RDF links document and an enrichment model identifier. The output is the given document enriched with the specified model. The other contract we have established is the model listing API, which uses a get method and outputs all the possible choices of models and their identifiers. Next slide, please. I move now to principles of the Lynx architecture, which are concerned with the security of the REST resources. One fundamental requirement in order to protect the REST resources is to establish a secure way of managing the authorization given by the source owner, like the user, to the client application. In Lynx, we have adopted the well-known OAuth protocol, which provides specific authorization flows for web application, desktop application, and third-party services. In between brackets, you can find some examples of this kind of clients for the Lynx project that we have addressed in the Lynx project. As an OAuth authorization server, Lynx uses Keycloak, an open source identity and access management solution. Next slide, please. One important requirement of Lynx is being able to define specific access control policies for fine-grained REST resources. One example of this is that each collection of documents should have its own access control policies. To this end, Lynx, to meet this requirement, Lynx adopts a centralized access control system based on Keycloak authorization services, which is a software module provided out of the box with the Keycloak server distribution. Okay, next slide, please. Okay, this diagram shows the internals of the Lynx access control system. As you can see, there are three main components: the API gateway, the Keycloak server, and the resource server, which in this case is the document manager. Furthermore, two human actors are shown: Alice, which represented some user, and the Lynx administrator. In this example, Alice asks for a get operation on collection 1, 2, 3. The API gateway receives the request and delegates to the Keycloak server the decision. The Keycloak server will use the data, authorization data it stores to decide and will send to the API gateway a positive or negative response. The API gateway will then act accordingly, and in case the response is positive, it will forward the request to the right microservice, in this case, the workflow manager. The other actor, the administrator, can use the Keycloak, the Lynx administrator can use Keycloak administration console to manage authorization policies attached to resource. One important thing to mention is that with this kind of architecture for access control, it is needed to synchronize resources, or better, to align resources stored in Keycloak with the actual resources provided by microservices. So the Lynx implements this alignment using the API gateway. Okay, next slide, please. Okay, finally, this point summarizes the key aspects of the Lynx architecture that we have discussed so far, which are the microservice architectural pattern, the REST architectural style, the API gateway pattern, service orchestration, the enrichment interface, the OAuth2 protocol, and Keycloak authorization services applied to the Lynx access control system. That's all for this section. I will now leave the floor to my colleague Victor Mireles from Semantic Web Company. Thank you for the attention.
Thank you, Filippo. Good morning, everyone. Unfortunately, I cannot show my webcam, but I will be guiding you through a description of the legal knowledge graph, which is, let's say, an integral part of Lynx, and it has some architectural interactions with the components that Filippo has just described. So, in the first slide, the next slide, please. Yes, thanks. So, the legal knowledge graph, let's say, it's a collection of statements about the documents which are organized in Lynx, and which are these statements and these documents are used to satisfy the different use cases. So these documents come from different sources, and the statements some of them are, or most of them are produced by the different microservices that were mentioned earlier and that will be detailed in the next webinar also. The ontology that is the basis of this knowledge graph is one can think of it as a data model that is used for information exchange between the Lynx services. So on one layer of the protocol, let's say everything, all communication is through REST APIs, so using HTTP protocol, but the messages exchanged between these services are encoded in some specific format, which is described by this ontology. So, and they're at the end of the day expressed in JSON LD, but the specific schema of this JSON LDs has to do with the ontology. And so this ontology is, let's say, the organization of the legal knowledge graph on the one hand, and on the other hand, it serves as the interchange format between the different services. It is based on the NLP interchange format version 2.1, and we have also developed a couple of Chackle shapes, which are descriptions of rules that can be used to validate that this legal knowledge graph is compliant with the ontology, and that the messages being exchanged are indeed compliant with this. So in the next slide, please. Okay, we can see let's say the interaction of this legal knowledge graph. So with the rest of the Lynx platform. So the statements that make up the legal knowledge graph come from a variety of sources, which are the different annotation services produced by Lynx and that make part of the Lynx platform. And another source are control vocabularies that are used to annotate these documents, to classify them, for example, categorize them. And these control vocabularies are managed by an instance of pool-party semantic suite, which helps in a user-friendly manner to manage these vocabularies. And these are also an integral part of the legal knowledge graph. These statements are served later by the document manager on the left-hand side, and these statements are actually used to power the different services and applications of the of the Lynx platform. In the next slide, please. Yeah, this legal knowledge graph, as was mentioned, is based on the NIF 2.1 ontology, and as such, its focus is on describing annotations on documents, but it is also interlinked with the LE ontology, which allows for describing the structure of documents and also its legislative related metadata. And it also links with the simple knowledge organization systems COS ontology, which allows to organize the different tags and concepts that can be ascribed to a particular document. In the next slide, please. Yeah, so as mentioned earlier, this legal knowledge graph is served by the document manager to power the different services and use case pilots in Lynx. And this use of statements and documents for services is kept synchronized by this document manager. And I will go a little bit later into detail about this. Yes, so this would be all from the legal knowledge graph point of view. And yeah, I will now leave the floor to Sotiris also from Semantic Web Company.
Good morning. My name is Sotiris Karabatakis, and I'm a senior researcher at Semantic Web Company. This is the last section of the presentation. Here we will describe the services that compose the Lynx basic platform. These services have to be considered as the foundational components of the Lynx platform, and they have a key role in the Lynx architecture. On the next slide, we can see the different basic components. These are the workflow manager, the document manager, and the authentication and identity manager. On the next slide, we can focus on the workflow manager. The workflow manager implements an API to instantiate the workflows and to monitor their instances. It is based on the Camunda technology. Camunda BPM is a lightweight Java-based framework. It can be used as a standalone process engine server or embedded inside custom Java applications. It offers non-Java developers a REST API and dedicated client libraries in order to build applications connected to a remote workflow engine. As you can see on the bottom of this slide, there are different endpoints offered by the workflow manager. One is grouped for tags, and the other is about instances. Tags can be think of a group of several workflow instances, so then you can actually query their status altogether or delete them and see the status of how much they have progressed in the engine and so on. The endpoint about instances, you can then instantiate a new workflow instance, define different parameters in order to modify its execution, check its status, and delete it again. This will be also demonstrated on the last on the demonstration of the platform we will see on the end of this presentation. BPMN is an abbreviation for Business Process Model and Notation. It is a graphical representation. Elena, can we move on to the next slide, please? It is a graphical representation that is used, thank you very much, that is used to specify business processes in a business process model. It is based on a flowcharting technique very similar to what you have in your mind by UML. BPMN has been designed to provide a standard notation readily understandable by all business stakeholders. Typically, this includes business analysts, technical developers, and business managers. BPMN can therefore be used to support common aim of all stakeholders on a project by adopting a common language to describe processes. On the next slide, we can see the population workflow we have defined for the Lynx platform. You can read this workflow from left to right. This is already described in BPMN 2.0. As you can see on the left side, the entrance point to the workflow is where you define the document, where you actually input the document into the workflow manager. This document has to be described in the data model that Victor described before. You just simply have to define the text of the document, some metadata about the document, and possibly some structured definitions of how the different sections and paragraphs of the document are structured in the document. Next, on the top of no, I'm still on the previous slide, Elena. Thank you. On this workflow, you can see on the top that there are different translation services and different annotation services. So in order to modify this workflow, you have just to define which of these services you want to use. After these services have finished their execution, all these executions happen asynchronously. Then we have to gather all the outputs and merge all the outputs into one single document. This happens on the step after the big block over the left. And the next step is to store this document into some document manager. For this, you have to define the collection IDs and the document ID of the document to be stored. The last step for this workflow is to store this document into some indexing, so you can then use the indexing service to retrieve the document. This ends the workflow, and as you can see, this is very easy to modify and define if the use case is something different, with different requirements, let's say, and do any modifications on this. On next slide, we can see the internals of the workflow manager. The client applications usually have only access to the workflow manager API. So the rest are orchestrated and managed by the workflow manager. The client application uses the endpoint we saw before, and then everything is managed from the workflow manager. So the workflow manager is responsible to route all these different requests for annotation services through the Camunda engine as it is defined on the workflow. Camunda internally uses also a database to store the definitions of the workflows, different parameters that can modify the execution of the workflow, historical data about previous executions, and so on. Additionally, it uses a service to store the documents because, as we said, all these different annotation services are working asynchronously. So one annotation service might end up earlier than a previous one. And then we need to somehow store these outputs into a cache. And in the end, all these are merged into a single document. So this is the basic of the workflow manager. On the next slide, we will see the document manager, which Victor will describe.
Thank you. So the document manager in the Lynx platform serves the purpose of storing documents, but also keeping them synchronized with their metadata. So the document manager is based on the Lynx data platform specification, and it consists of a thin REST API wrapping this Lynx data platform, one Lynx data platform implementation in particular called Trellis LDP. The metadata about the documents, along with other statements which constitute the legal knowledge graph, are also stored or are stored in Jena Fuseki triple store. The document manager is also in charge of taking care that documents are compliant with the ontology, so doing some sort of data validation, and also making sure that they can be processed by other services. So let's say the Lynx data platform implementation, which is underlying, or any Lynx data platform implementations, is very flexible in that it allows for, let's say, arbitrary documents and the metadata about these documents to be stored. But the document manager imposes some extra requirements on this to make the documents and their metadata much more usable by the other services. And yeah, in the next slide, Sotiris will talk to us a bit more about authorization and identity.
Thank you, Victor. Last but not least, the last component of the basic platform services of Lynx is the authorization and identity service. This implements an interface to manage the different digital identities, which is the clients and user accounts. And then you can also define different authorization rules. Let's say different access rules for the resources of the platform, different policies, and different permissions for each resource. Since authorization is centralized, the resources need to be synchronized with other microservices. The synchronization then is operated by the API manager. It acts also as an authorization server of the OpenAuth 2.0 protocol. On the next slide, we can see the core concepts of the Keycloak implementation. We are using Keycloak for all this management of resources and authorization. As you can see, Keycloak can offer different identity providers, namely OpenID, SAML, or different login, social login applications such as GitHub or Facebook and so on providers. And from this interface, you can define all the different roles, the access to services, annotation services, and so on. On the slide that Filippo mentioned earlier, as you can, the typical use case is that we might have two different users of the platform, and we need to restrict access into some collection. So everything is managed through this. The very critical point on this authorization manager is that it never reaches the actual service. The API manager it acts as a gateway, so even before the request reaches the annotation service, it is authorized. So the developers of the annotation services or any other service on the platform does not have to care about authorization. This is all managed by Keycloak and the API manager. This concludes the presentation about the basic platform components of the Lynx platform. Next, we can see the demonstration of the basic platform. In this, we will see how we can instantiate a new workflow instance to check how the authorization works and check the status of our workflow. In the end, we will see how we can get the document from the document manager. If you can, Thomas, start the demonstration. Thank you.
This is a demonstration of the Lynx platform services. You can find all of the available services if you go on our website, then click on Resources and Services APIs. Here you can see all of the available APIs. The basic platform services are the Workflow Manager, the Document Manager, and the Authentication and Identity Manager. We will use the Postman client to make all the requests today for the demonstration. You can easily import all of the specifications of the APIs in Postman by using the import function and then import the link here of its specific service API. I have already imported the APIs for the Document Manager and the Workflow Manager. The Workflow Manager offers two endpoints. One is about instances and the other is about tags. Let's now create a new population workflow instance. This is a post request. You need to define some parameters to modify the population workflow, and you need also to provide some input for the body of the request. This is actually the Lynx document that we will use for this demonstration. As you can see, this is a JSON file. It contains different metadata that describe the document. It also defines some parts on the text, which is actually the paragraphs or different sections of the document. And here is the text. As you can see, the text is in Dutch. On the top of the document, we can see the metadata of the document. This looks like a simple JSON file, but in fact it is a JSON LD. It is RDF. Next, we need to define the parameters of the call. Here you can see all the different parameters you can define. The first one is called Document Platform. Here you can define the different document platforms that you want to use in order to store the document. For the demonstration, we use the LDP implementation.
As you can see, I'm using environment variables and this is set to be LDP. Next, we need to define the collection ID. This is set to be webinar. For the demonstration, we do not want to index this document into the search service, but we want to use the entity linking service. For this, we need to provide the entity linking project ID. This is the ID of the consent scheme we want to use in order to annotate our text. We need also to provide some ID of the model that we will use to translate the text from Dutch to English. For this, I need to check out this. We do not want translation to other languages, just in English, and I need to provide the model. Here you can see the idea of the translation model. There exist different models for that map input language to output language. We do not want to use other annotation services, just the entity linking one, so I'm also switching off this. And we set the tag to be webinar again, so we can check its status later. This is set to be webinar again. So now I'm ready to execute the call. I click on send, and as you can see, my request was rejected because I was not logged in the platform. This response was 403 forbidden access. So for this I need to be authorized. I go on this collection and I just use the Keycloak to get a new token. As you can see, all these parameters are already pre-filled by the OpenAPI specification of the call, and I just need to log in. I get a new access token. I need to provide my credentials. So now I got the token and I will use it for the call. Here I also need to specify the token. As you can see, I can just use to inherit the auth from parent. So if I click on send, you can see that my request was accepted. I got the workflow instance ID, which I will save to use it later. And we get also the document ID, which I will also use. So now we can check the population workflow. We should go on this request. It is a GET request. The only thing we need to provide is the workflow instance ID. If I click on send, I get the response, and we see that this population workflow instance has already completed. If there was any error during the execution, this would be reported here. Now I will switch to the document manager. I will open this API, and as you can see, the Document Manager API offers 3 different endpoints, one for collections, one for documents, and one for annotations, where you can actually do different CRUD operations on each of these instances. So here I just want to get the document that we ingested before with the population workflow. There is this endpoint about documents where I can get to retrieve the existing document. So this is just a GET request. I need to provide the collection ID, which is set as before in webinar, and also the document ID, which is also the ID that we got from the population workflow. This is actually the URI of the document, so it is the ID that you will see on the RDF representation of the document. If I click on send, I get a 403 forbidden because I have no access to this. But if I log in, I will use again Keycloak for this and get a new access token. So now redo the request, and as you can see, I can now access the document. This is in RDF in turtle representation. And as you can see, there are already annotations from the entity linking service. You can get the document in other serialization as well if you define a different header in the accept content header. So here we can define this to be application LD plus JSON or simply JSON. It's equivalent for our service. And you will get this document into JSON LD. Here you can see it is the same document we had before, but this time it contains also annotations from the entity linking service and the translation from the translation service. Here are the annotations that were produced by the entity linking service. It found about 26 different annotations from the document, and here we can see also the translation that was produced by the translation service. It is in English. Thank you for watching this demonstration.
Okay, thank you so much. Guys, Sotiris, Filippo, Victor, for this very clear presentation, for these detailed insights into the Lynx Services Platform and Lynx API descriptions. I hope our audience enjoyed the webinar. I'm not sure I'm sharing my screen.
You do.
Okay, great. Thank you, Thomas. Because I wanted to tell our audience that we have some webinars coming. So there is another technical webinar next week on Thursday, at 10:30, where the services will be also shown in detail. Yeah? So now it's we still have about 10 minutes for questions. Any comments from the audience? We will be more than happy to get them. Yeah, I see one question coming in. Okay. So if I have a system and I'm interested in integrating a couple of services, let's say translation and entity linking, how easy or difficult would this be? Who would like to take this question?
I think I can take it, Elena.
Thank you.
One principle of the architecture was interoperability. We are using the REST architectural style exactly for this purpose. We want clients to easily integrate with the Lynx. So it's as easy as integrated with a REST application, I would say.
Mm-hmm.
Did I answer the question?
I think so. Yes. Okay. Any other questions? We still have some time left. Mm-hmm. Okay. Here we have another question. Yes, what is it needed in order to deploy the whole platform in my own infrastructure? Who wants to take this one?
I think I can take the question.
Okay.
Okay, our the Lynx microservices are deployed in OpenShift platform as a service instance. So the whole platform can be moved, can be deployed to other systems just by deploying the OpenShift and importing, let's say, the project. It should be easy, I guess. So you just have to deploy OpenShift and then import and export the project.
Okay. Yes. Okay. Thank you for that, Filippo. Any other comments, questions from the audience? You can always, if you, by reviewing this video, you have some questions, you can always reach out to us. Yes, you'll find the contacts on the Lynx project website. And as I said at the beginning, the recordings and the slide decks will also be available. We'll send an email to you with the corresponding links, yeah, to slide deck and recordings. And there are also links to the previous webinars if you missed any. Okay, so if there are no more questions, I think I'll thank my colleagues again, thank the speakers again for this very nice presentation. I will thank the audience. I hope you join us again next Thursday at 10:30, and also for our final event, yeah, on the 17th of March. Yes. So thank you and enjoy the day. Bye-bye.